Bees are in crisis. Bee populations have been declining in Europe since the 90s, putting at risk our agriculture and way of life. The decline of bees concerns us all as they play an essential role in our agricultural systems and the environment. Bees help pollinate crops and maintain balanced ecosystems. In Europe, around 84% of plant species and 76% of food production depend on pollination. Researchers estimate that if we do not address the bee crisis and mortality continues to increase, the economic impact will be the loss of approximately €150 billion worldwide. We are facing a complex problem that requires new solutions. A European-funded project has designed new sets of tools to improve monitoring and help address the challenges bees face. The Internet of Bees, or IOB, is a multidisciplinary project that has developed a three-stage solution to increase our knowledge of bees and their relation with their environment. IOB introduces a variety of tools so that beekeepers, associations, researchers and policymakers can have a closer understanding of the environmental challenges that affect bees. IOB is a new approach that integrates different monitoring solutions. Its main objective is to disrupt the beehive monitoring market with a never-before-seen integration of different technologies. IOB is applying technological innovations linked to the Internet of Things to beekeeping and environmental monitoring.
So imagine bees connected as if they were actually an internet of hives that will report to the beekeeper what is happening to them, and the collective information of all the hives gives you a great picture of what is happening, not only in an apiary, but in a region where you have beekeepers that can be associated, for instance. And then you can upscale this kind of networking to national and even into international levels, where we hope that one day IOBs could be a standard in Europe.
IOB integrates 3 different levels of monitoring and data analysis for assessing bee health. It combines in-hive and field monitoring with satellite mapping, applying special decision support systems to bee-related data. IOB has produced and continuously improved cutting-edge monitoring systems for beehives. The Bee Counter is a monitoring system installed at the entrance of the hive that allows beekeepers to monitor their bees in real time. The Bee Counter tracks incoming and exiting traffic, providing valuable information for assessing the health of the colony. The beekeeper can then evaluate the strength of the foraging force, determine mortality rates in the field, and identify deviations in flight duration and nectar availability. The Bee Counter sends collected data to a cloud server via cellular network. It is then automatically processed and visualized through a user-friendly way. Digital monitoring brings beekeepers closer to their bees. They can access the information at any time from their internet-connected devices and foresee which actions they should take next. IOB's Bee Counters provide up-to-date information on the status of the colony. IOB has continuously tailored its bee counters for the actual needs of beekeepers. Major representatives of the beekeeping sector have given direct feedback. IOB has collaborated with national associations throughout 7 European countries to test the bee counter. IOB has also developed an e-gate, a sensor that identifies insects entering and exiting the colony by colour detection. The e-gate works with RGB colour code balance. It can determine if the hive is receiving unexpected guests, such as pests. IOB has also aimed to improve observations of conditions beyond the hive. An optoelectronic sensor automatically provides insect count and identifies different species. An in-field digital sensor measures the diversity and density of pollinators in the field. Monitoring pollinator availability is essential, considering the importance of not only managed but also wild pollinators. The sensor is a new user and insect-friendly response to the challenges of traditional traps used to count pollinator density and diversity. It identifies flying insects without disturbing them. Therefore, there is no need to trap, kill, nor manually count insects. As insects fly through, the sensor automatically identifies their flight pattern and matches it with a species in the database. The sensor is also able to detect plagues that affect bees, such as the Vespa velutina or Asian hornet. This invasive species has become a challenge for bees and beekeepers. It continues to spread around Europe, meriting further attention and new detection systems. The sensor allows for early detection, which improves the chance for effective responses from individuals, associations, and authorities. Both in and off-hive sensors work in synergy with the third stage of development in IOB. Monitoring parameters such as bee traffic and activity and the diversity and density of pollinators is jointly developed with satellite imaging and the application of special decision support systems. By applying a predictive model to data recovered by satellite imaging, it is now possible to provide a more extensive tool to understand the environmental condition of bees. This last stage of IOB makes it possible to determine the surrounding land use of a location. The beekeeper, association, or other users can find out if a site is, for instance, surrounded by monocultures. Users can also discover the land cover types, whether this is, for example, grassland, forest, bare ground, or others. Finally, this tool provides users with historical data on phenology, as well as a predictive model. They are now able to determine the availability of resources such as pollen or nectar, which directly influences the overall well-being of bees. IOB introduces an integrative logic that goes from the hive to the surrounding environment. The parallel development and integration of monitoring tools is a crucial element for IOB. These new tools have only been possible to achieve with close collaboration with beekeepers around Europe. IOB is an interdisciplinary project with partners from different countries of the European Union. It includes private firms, academia, and non-governmental organisations. We need bees for the future, and innovation is becoming essential to ensure their protection. IOB is integrating different solutions to make a better future for bees, the environment, and ourselves a reality.